My name is Michael Clark. I'm an IT operations and tech industry consultant with Renaissance Tech and Media, where we help companies and organizations struggling with cybersecurity challenges to operate more safely, securely, and efficiently in the world of hybrid multi-cloud computing. Today, I am here with Brett Hamill, Senior Solutions Architect at Genians, a company that has helped over 1,600 customers around the world since 2005 to secure their network edge. In recent years, network visibility and surveillance have received increased focus and attention. Especially relevant to this discussion is IoT, the Internet of Things, and specifically how to accurately identify and manage IoT and other devices that connect to various network environments. Having detailed, accurate, and actionable information regarding what devices are connecting to your network is critical. Today, we are going to share how Genians' device platform intelligence helps meet such challenges head-on and thereby enhances your network access capability challenges in the area of device fingerprinting specifically. And with that, I'll turn things over to Brett to begin our presentation.
Thank you, Michael, and thank you everyone for joining today. As Michael discussed, today's topic is next-gen device fingerprinting for the IoT era. Today we'll have a combination presentation and we'll take a look at a live system. Typically the session comes in under 45 minutes, depending on how many questions we have. And with that, I'll go ahead and get started. So most of you on the call probably understand what device fingerprinting is, especially relative to network access control. We covered a little bit of that on our previous webinar. But today we're going to talk about next-gen device fingerprinting, why that is critical, what the difference between next-gen device fingerprinting and legacy device fingerprinting is, and how that can affect your cybersecurity plans. So obviously, one of the things that device fingerprinting is used for is to detect and fingerprint unknown devices. So unknown devices are part of the picture. What we find is that devices that are end of sale and support or have vulnerabilities are really the crux of the pain point for most cybersecurity professionals who are dealing with devices connecting to their network and attempting to mitigate the risk of those devices and determine what to do with those devices. So an easy way to highlight that is to discuss some of the high-profile scenarios that have occurred in recent times. So the NASA Jet Propulsion Lab data breach was actually caused by an unauthorized Raspberry Pi device connecting to the network that the IT staff did not know about. Once they did subsequent audits, they actually found a bunch of other devices that they also did not know about. So the first category that we talk about, which is unknown devices, not knowing that they're there, legacy device fingerprinting can do an adequate job of identifying devices, but really that only paints part of the picture relative to what we need to be concerned about with regards to devices and what types of devices and the status of those devices when they connect to your network. If we talk about specific vulnerabilities, another high-profile one was the Equifax breach. So there was a particular device that actually had a vulnerability that was exploited. So this is where legacy device fingerprinting really doesn't get the job done. You're really relying on a separate system like a vulnerability scanner generating reports, and that has to be analyzed to be able to make that information actionable. So you have to know that devices are on the network, you have to know if they're vulnerable, and you have to be able to do something about that. Additionally, end of life, end of sale, end of support devices are a huge concern. Even Cisco Systems, comments on how most organizations have no idea what's really out there relative to end of life, end of support, and whether those devices are actually supported and patched and up to date. And further echoing that sentiment, the Online Trust Alliance, their most recent study found that there was two million cybersecurity incidents totaling in 45 billion in losses in 2018. That's not that in itself is an issue, but the real problem is that 95% of those were avoidable. So there's several categories that and several root causes that can be addressed, but two of the ones that keep coming up over and over again is that devices are end of life and thereby unsupported, and they're sitting on the network. And then also, even though there may be vulnerability scanners that organizations are using, there's no good way to process those huge reports that may be thousands of lines long and to take action. So having multiple systems, having to identify your assets, what is end of life, having to identify devices that may have vulnerabilities, that is the challenge. So that is why it is important to have this information. Aside from that, it's really just a best practice. So across all the different regulatory compliances, the Center for Internet Security has identified basic controls that should always be adopted. So yes, there's a lot of horror stories out there and it's scary, but also these are just best practices and they should be followed. So throughout the course of our webinar series, we're going to be talking about all of these different controls. This particular webinar is going to focus specifically on knowing what types of devices and assets are on the network, and then also being able to manage the vulnerability of those devices. In subsequent webinars, we'll talk about some of these other controls, but today it's really going to be focused on visibility, vulnerability, and being able to identify devices on the network properly. So how does network access control correlate with these core cybersecurity requirements? What we've done here is we've correlated the core requirements to network access control features. Specifically, inventory of hardware and assets on the network, network access control systems. Most of them can detect all IP-enabled devices on the network. Whether or not they can identify the very specific platform, we'll talk a little bit more about that in the upcoming slides. Also, being able to continuously manage the vulnerabilities. That is a more challenging piece. What we'll talk about today is how a product called DPI with Genie and Znack can actually link devices that have been detected and then link those with known vulnerabilities and also identify whether those devices are end of sale or end of support. We talked a little bit about on our last webinar about the foundation here for cybersecurity. Today, we're going to be focusing strictly on surveillance, and we'll be talking about control and automation in subsequent webinars. Again, if you implement these foundational steps, you can defeat 85% or probably even a higher percentage of common attacks. So when we talk about network surveillance, we're talking about being able to cover the various portions of your network, whether it be wired or wireless, managed or unmanaged. And we're also going to be talking about the basic information, the who, what, when, where, how of a device and its compliance status, and to identify whether it's unknown or misconfigured or rogue. So those are the basics of network surveillance. What we're going to be talking about a little bit more today is how device platform intelligence can enhance typical network surveillance and provide additional actionable information, especially valuable in the IoT era. So let's talk about what is device platform intelligence and what information does it provide. We've already identified that this information is critical and it's important to have. So you need to have information about what is connected to your network. However, the quality and the extent of that information is what will determine how that information is actionable and how you can craft your network access control policies. When we think about legacy device fingerprinting, really devices typically get identified and thrown into buckets or categories, and then there is some action performed. The difference between device platform intelligence is that it's actually its own entity. So this is a highly correlated database that correlates information above and beyond just high-level device type. You're going to get information about the manufacturer. You're going to get actual pictures of the devices. You're of course going to get your typical information about where the device is connected. You'll get the manufacturer country of origin. We're going to be focusing a lot today on the end of sale, end of support capabilities of DPI, as well as the ability to link specific platforms to vulnerabilities. So this information is one of the things that distinguishes DPI and makes it a next-gen device fingerprinting platform, and differentiates it from legacy device fingerprinting. Also, one of the common themes we'll be talking about today is that there is no complex network integrations required to obtain DPI for active nodes on the network. And we'll explain a little bit more about how that's possible. So I talked about how DPI is really its own product. So what it does is it correlates information in a cloud database maintained by Genians that has been built for over a decade, that gets updated weekly. We've added over 4,000 platforms in 2019 alone. It's also a searchable database. You can actually search for products, find out more information about specific products. You can even screen devices before you connect them to your network. And we directly link CVE information to the CVE website, where you can, the NIST.gov website, where you can review details of CVEs. You can also suggest platform updates through the interface. So this type of information is definitely not legacy fingerprinting. This is what we consider next gen. Seeing a picture of a device, getting information about end of sale, end of support, knowing how it was fingerprinted, knowing where the manufacturer is headquartered, having this searchable database for specific platforms, and then also specific vulnerabilities that are linked to platforms already in this database without any additional configuration or work by the customer using the product. That is what we consider next gen. So continuing along the lines of the vulnerabilities and how important those are, I'm sure this product list here is going to look familiar. So just about everyone, I'm sure, has multiple products in this list on their network right now. And if you look at the number of vulnerabilities, the severity of vulnerabilities for these products, that is a cause for concern. So the challenge that cybersecurity professionals and managers have had is, how do you actually sift through this information? How do you easily make it actionable? And going through thousands of lines of vulnerability scanner reports is one of the things that has been documented over and over again as being prohibitive and non-productive, and therefore devices that are vulnerable just sit on the network.
Interesting. Brett, if I may, a question. The information pertaining to correlating CVEs seems particularly valuable. Is there a way to make this information actionable? In other words, if a device connects to the network that is correlated with the CVE, will some kind of action based on that information then be performed?
There certainly is. So that actually is the challenge, right? How do you make it actionable? So what we'll cover here in some subsequent slides and in our demo, we'll show how that information can be actionable. Having this information is only as good as the ability to do something with it. So we've determined now that this information is critical. We determined what this information is that we want to obtain. Now we can discuss, how do we obtain that information from the network? If we look at the architecture of a typical Genie and NAC on-prem deployment, cloud deployment is almost identical, the exception of your policy server being in the cloud instead of on-prem. One of the things that differentiates this solution from other similar solutions is the ability to non-intrusively collect a bunch of this low-level information that feeds the device platform intelligence database and identifies those specific platforms that are on your network. So being able to get this information without actually having to touch all of your networking equipment, configure high availability because you've got a single point of failure, and do this easily without a lot of networking knowledge or having high-level networking experts involved or network access control experts involved. That's always been the challenge. So with the sensor approach, you're able to quickly and easily connect a sensor to various locations in the network, and then it starts to passively collect information about all active nodes. You can detect up to 128 VLANs per sensor, and what that gives you is the ability to, either in a passive or an active mode, monitor ARP broadcasts and other traffic that feeds the DPI database and allows you to know what platforms are identified on your network. That information is then automatically correlated to vulnerabilities and end of sale and of life information. If we contrast this to some other methods, so for example, we're using Radius here, what you really have is a much more complex integration, even just to get basic information like Radius accounting that tells you that devices are connecting to your network. So for this type of architecture, you have to touch every switch or controller or access point. You have to point that information to the Radius server. You typically have to configure high availability because now you have a single point of failure. And this is a very intrusive, high touch architecture to implement. And that's just for basic visibility. On top of that, to get more information, you typically have to integrate with DHCP servers to be able to get DHCP fingerprinting information or configure profilers on your switches or other devices to profile information. And again, that's really only for basic legacy, what we consider legacy device fingerprinting. In subsequent webinars, we're going to be taking a deeper dive into all of these different types of NAC architectures. But the one thing to note is visibility, right? Being able to identify networks, devices that are on your network, that is the key. That's the focus of this webinar. And that is actually should be the first focus of any good cybersecurity plan, is to know what's on your network. So some of these other architectures are very intrusive and have a bunch of considerations and challenges. Configuring all your devices, high availability, may not be vendor agnostic. You have to have switches that support features. Every time you refresh your network, you may have to reconfigure things. Is it low touch? Can it be cloud managed, et cetera, et cetera. So one of the things about the sensor architecture approach is it addresses almost all of these concerns. You may need to implement a sensor at every location depending on your architecture, but aside from that, really all of the other concerns are mitigated by this architecture, and it gives you very quick visibility into your network without a network integration team of professionals.
So powerful stuff, Brett. Let me just take a moment and confirm what I hear you saying regarding how DPI is obtained from the network. There's no network changes at all required, right?
That's correct. So typically what you have to do is you have to configure all of your network devices to feed whatever system you're using to fingerprint devices, or integrate with DHCP servers or other profilers. In this case, really the only thing you have to do is connect the sensor to your network with either an access or a trunk port, just like you would a server or a switch. So really only basic networking skills required and no real network integration needed.
Okay, great, thank you.
Mm-hmm. Let's talk a little bit about how DPI obtains the information that it obtains. So there's a passive mode and an active mode. So in a passive mode, there's a surprisingly large amount of information that gets generated by any device that connects to your network. So one of the first things that it's going to do is a device is going to send out ARP broadcasts to find out what its gateway is, to find out other information. So even in passive mode, just listening to this information, there's X amount of information that can be extrapolated from the traffic that's generated, along with some additional secret sauce we're not listing here, that can actually help us identify and link a device with a particular platform type. And remember, platform is not device. We'll talk about that more. Device type is very high level, platform is very low level. If you go into an active mode, we actually get more granular information. So you can enable scanning and use other methods that will further enhance and refine the initial platform detection and maybe refine it down to a more granular level. So this is typically implemented in a staged fashion, but neither one of these requires any network integration. So typically what most customers do is they turn it on in passive mode. They identify a bunch of platforms on their network. If they feel they need additional information, they can go to active mode, which will give more granular information. And then optionally, you can enable policy enforcement once you're in active mode. We'll talk more about that in subsequent slides. Okay, knowing that this information is important, knowing that it is easily obtained from the network, now that we have this information that's very difficult to obtain typically, but not with Genians, what do we do with it? How can we enhance our NAC policies with the DPI information we've obtained from the network? We've got 3 use cases here. There's many. This is just to demonstrate the difference between what is typically what we consider a legacy approach relative to identifying devices and fingerprinting them on the network, and how device platform intelligence can differ from that. So because you have increased granularity about specifically what kind of platform it is, you're not talking about a basic category, and you're able to get more specific. So many times, relative to printers, you'll have a printer fingerprint, it'll get classified as a printer, and there will be an action performed like put it into a printer VLAN. What you can do with DPI is you're going to be able to distinguish between all these different printers, manufacturer, make, model, etc. And then you're able to actually do something with that information. So you can define authorized printer platforms and unauthorized printer platforms, and then you can actually assign specific permissions. Those permissions follow that platform no matter where it goes on the network. Because the permissions are set in the software, you don't have to apply ACLs or deal with radius or touch your network at all. This is software-defined permissions that are enforced by the Genie and NAC system. Now you may think, well, what does this really buy me? Most printers out of the box today have things like HTTP enabled. So one of the huge things that gets brought up over and over again as far as preventable cybersecurity issues is having devices with HTTP enabled on your network. So perhaps there is a specific printer manufacturer model that you want to allow on your network, and you know it's been vetted, you know it doesn't have vulnerabilities, and you don't want to allow just any HTTP enabled printer on your network. You want to be able to restrict that or deny that. This use case can address that. We'll look at this live in the system momentarily, but basically you categorize your devices. You have authorized printers, can be your specific platform. And then unauthorized printers can be all other printers that are not part of this specific, not this specific platform. Once you categorize that, then you can actually do whatever kind of permissions you would like to do. So in this example, you're restricting access to the internet, so your internal network cannot be compromised, but that of course could be a deny all permission. This is not very complex. You don't need to be a NAC expert or a networking expert to be able to configure these policies. Another use case is for end of life, end of sale, end of support platforms. So when we talk about legacy fingerprinting, this information is typically not part of the picture at all and not available. So a device type is normally assigned and that's it. So if you are able to do this, typically it's going to require some kind of a third-party integration if available, and then that may cost more, and then there'll be some kind of action like assign a VLAN. With DPI, because you have more granular information, you're able to link specific platforms to an end of sale or end of support or end of life. You're able to group those together, restrict access, and the permissions follow the platform around. So again, the key here is being able to assign specific platforms. That gives you the power to be more granular with your network access control policies, and you can restrict or deny any end of sale, end of support device on your network. So what you can do here is configure end of life states. You could say end of sale, end of support, or we even have an out of business category because we're tracking that. Once you group those together, then you assign whatever permissions you like. So in this example, it's internet only, or you can just say permit all while you're just monitoring or looking at devices that are end of sale, end of support that you want to proactively remediate before you get into too much trouble. And then our final use case here is for vulnerabilities. So this is what I consider one of the most powerful features with device platform intelligence and next-gen device fingerprinting, is to be able to pre-correlate and pre-link devices with vulnerabilities. So again, legacy fingerprinting, this is not a feature that typically comes with it. So the third-party integration, if there is one available, there may not be. You may need to have a network access control system and then separately have a vulnerability scanner. And what happens then is you run into the problems we discussed at the beginning of the webinar, where you have thousands of lines of a vulnerability report that you have to go through. And many times that takes too much staffing, just doesn't get done. And as a result, there's a bunch of vulnerabilities that are on your network. So with DPI, because again, we actually have that pre-correlated in the DPI database and it's tied to the specific platform, you can group these together. Then you can decide what to do, restrict or deny access, and the permissions are in software, not on the network, so they follow that platform around no matter where it goes. That's the common theme. With Genie and Znac, you're going to leverage device platform intelligence to actually know any and all CVEs that are published and whether the nodes on your network are affected. So every single CVE that gets published will be listed. You can determine whether or not any nodes are applicable, and then you can drill down and take action. So if you see a CVE published and you see 0 nodes, that means there's no nodes active on your network that are affected by that CVE. You don't have to worry about it. Once you find a node on your network that is actually affected by a particular vulnerability, you can dig a little deeper and you can see what the vulnerability is. So we have a device, we have some end of sale information, but this example is going to be specific to a particular CVE where this camera can allow anyone to view audio or video without authenticating. So that's a pretty critical vulnerability. We can actually create a group and we can tie platform security vulnerability to a particular vulnerability ID. So that's very powerful. Not only do you know that it has vulnerability, but it's a particular vulnerability, and then you can define whatever permissions you want. Once you group that together, you could say this is a particularly nasty CVE, so I just want to deny all for any device that may be affected by this CVE on my network. So now we're going to go ahead and take a quick tour of the UI and look at some of these configurations live and discuss some other items. This is a cloud demo system. So this is a Genie and Znac server in the cloud. There's of course all sorts of things we could cover, and we're going to talk about a lot of this on subsequent webinars. But today we're going to be focused particularly on device platform intelligence and those use cases. So we're going to look at those, but stay tuned in subsequent webinars for a more detailed tour of this UI and different enforcement policy options. By dropping a Genie and sensor onto your network in passive mode, it's going to collect all sorts of information about nodes on your network. And this is without any network integration. Once these nodes start to populate, you'll have an idea of what devices are connected to your network, and you'll be able to configure some of the policies that we discussed. So there's many different policies here that have different uses as the names may imply. So you have an enforcement policy, you have a group that is a matching criteria, and then you have a permission that you can assign all the way down to a particular time of day. You can get very granular with these permissions. But today, we're really going to be focusing on this middle section. So we're going to be talking about the printer scenario, we're talking about the end of life scenario and the CVE scenarios, and we're going to take a closer look at what that looks like. So remember, we actually discussed creating a policy for printers. This is that policy. This is very easy to create. This is wizard based. So we talked about any device that, even though it's a printer, if it's not in my authorized printer platform, we're going to actually restrict it to internet. So that's a very easy policy to configure. Once it's configured, devices that match that policy are going to show up. So this is a node that's on the network. This node that's on the network today is actually a Canon printer. So what that means, let's refresh this screen. What that means is, yes, this is a printer. However, this is not the specific platform that I authorized as a authorized printer platform. So that gives you the ability to know that someone connected a printer to your network. It probably has HTTP enabled, and then you could do something with that. Your pre-screened authorized printer platform, which was the HP specific model platform, those devices would be able to connect to the network, but you can optionally restrict this one as the example policy showed. If we look at our end of life, end of sale devices, so what we did there was we wanted to identify, are there any devices that are end of sale, end of support on my network? And if so, let me do something about it. So we have a couple of devices that matched on this policy. So what we see here is we have two networking platforms that are on the network, and they're actually end of sale. So if I click on this, this will take me directly to the Genius DPI database and give me the detailed information that was obtained. So you can see this particular platform, it is end of sale, but it's not end of support just yet. So what this allows you to do is, before you get into trouble, and like some of those examples we talked about early on in the webinar, and you get compromised or have a data breach or some other cybersecurity incident because you have an end of support unpatched device in your network, you're able to mitigate this ahead of time. You're able to identify this, and you're able to take action before that becomes end of support and actually use that to protect yourself. Here's another different example. So those were networking devices. So you could basically just restrict those or just permit all until you can remediate those. Or once they've reached end of sale or end of support, you could do something more strict with them. But for a device with an end user behind it, like Windows 7, you can actually treat those a little bit differently. So with Windows 7, you know it's coming up as end of life, so you can identify that end of life platform. You can put a captive portal in front of the end user and let them know. If this is not a managed device and people need to self-remediate because it's a BYOD environment, this allows them to actually know that they're going to be in trouble and they need to upgrade. And here are the upgrade paths. So you can actually educate your end users and protect your network at the same time. And when we talk about the CVEs, that was another policy. We talked about a specific policy. So this is a particular CVE, and I want to deny any devices that match on this policy that have that CVE. So we see there's a device here that is on the network that matches on this. So here's the camera that we looked at earlier. If we click on that, we can actually see that, yes, this is end of sale, end of support, but also, more importantly, here's the vulnerability. So we've matched on this vulnerability, and we can use that information to quarantine this device on the network at layer 2. So the important part about this is this information's all been pre-correlated in the DPI database. You did not have to run a vulnerability scan. You don't have to manually correlate a vulnerability report with the active devices on your network. That's all been done for you in one solution. If you wanted to create a larger bucket, you could. So you could basically say any devices that have a vulnerability period. So if there's CVE is included in the description, then match on this policy. So there's actually a surprising number of devices out there that have vulnerabilities associated with them on any typical network. If we pick this one, which is an Apple iPhone, and we look at it, this matched on the policy. The iPhone is out there, and it's got these vulnerabilities associated with it. So what you can do is then take further action to make sure that this particular vulnerability, this vulnerability is not something that is affecting the particular version that your iPhones may be running. So really that covers all the different scenarios and gives you live examples of how that information could be obtained through DPI, what we can do with it, and how easy it is to be able to identify this information using next-gen device fingerprinting or device platform intelligence and protect your network with the appropriate NAC policies.
Great, thanks, Brett. I think we have some time for questions. We have a few that were submitted in advance of the webinar today, and we certainly can entertain some more. So if people do have questions, please populate the Q&A box at the bottom of the screen. This first question that came in is the DPI information for devices on the network ever inaccurate? If so, is there a way to override the platform type that gets associated with that device?
Well, absolutely. There can be scenarios where DPI is not accurate. It's way more accurate than a typical standard DHCP fingerprint and more granular, but there's always a possibility that there was something wrong with the matching criteria. So for example, if you have a scenario where you have a device that may not be the platform that was identified with the DPI, you're able to override that information. So in the device platform intelligence section of a particular node on the network, there's what is identified, but you're also able to do a user-defined platform. So you could plug in whatever you want here, and you could say, hey, this isn't an ASUS RTAC68P, maybe it's an ASUS something else or some other kind of router. So you can actually define this particular platform. Not only that, but you can actually report an incorrect platform. So in addition to defining this, you can click the report incorrect platform button. What's going to happen is all of the information used, the low-level detailed information used to correlate that device with a particular platform, will be sent to our team of DevOps engineers, and they'll actually rectify that. You can include your suggested name, tell us any other information, hit submit, and that will automatically open a ticket with our DevOps team.
All right, good to know. The second piece that came in here, is there a historical record of any kind when new devices are detected, or if the DPI information associated with the device changes?
Yes, every time a new platform is detected, that is logged. So one of the pre-configured log filters that we have in our system is new platform detected. So anytime that happens, there'll be a log entry indicating that there was a new platform detected. Also, if anything changes, it's logged here. So if we look maybe for an example of one that was refined further, phone. So here's an example of a device that originally came on the network and was identified as a Grandstream voice device. through additional information that it gained from the network, it was able to further refine it to a particular grand stream model. So, and then of course it redefines that, and that is the new platform detected. So there's the historical logging. This all happened, by the way, in 1 second. So this is not a lengthy process. So this is another example of how DPI is much more granular than just configuring something that says VoIP phone. So if you have a DHCP fingerprint category that says VoIP phone and you allow those and plug them into the voice VLAN, you could have someone bringing their own VoIP phone and plug it in, and then it'll have full access. But if you only have a particular manufacturer and model of VoIP phone that you want to authorize on the network, that is why DPI granularity is so important.
Okay. And finally here, can the system be configured to send notifications to admins or external systems when new platform types are detected?
Yes, you can take any kind of filter, log filter, so any event that you want to create, or any pre-can log filter, you can actually send out notifications on that information. So you can customize this, call it whatever you want, give it any kind of description you want. You can identify what information you want to be displayed. Once you define that criteria, you can actually send that information through SMS or email to system administrators, help desk, etc. You can customize the content that goes out in that message. You can also do syslog, SNMP, webhook, etc. So you can export this information into external systems. So you could take the inherent value of device platform intelligence, which is much more detailed and granular than device fingerprinting, and you can actually feed that to external systems so they can utilize the platform specific information.
Okay, thanks. Nice, Brett. So it appears that we haven't had any additional questions come into our Q&A box. So in that event, that completes our Genius Next Gen NAC Device Platform Intelligence webinar for today. Thanks to those who were able to attend, and thanks to those who offered up some good questions for us. For our next webinar, which you can see on the screen being advertised for January 8th, we will discuss how to lock down any non-compliant or compromised devices that may exist in your environment. So stay tuned, watch your email for more information about that. In the meantime, thanks again, everyone. This is Michael Clark.
And Brett Hamill.
Thanks very much.